In this video, we will cover the concepts behind underfitting and overfitting. When we take the situation of regression analysis in machine learning, underfitting and overfitting can be described in the graphs as represented here. The cross marks are the data points and the red line is the outcome from the machine learning algorithm. In the graph for underfitting, you can see that the machine learning algorithm does not capture the trend behind the data points and it does not covers most of the data points. So the outcome from the underfitting algorithm will not be accurate. And in the right, if you can see, in the overfitting algorithm captures all the data points and so it may lead to inaccurate outcome. The reason being the machine learning algorithm will also have captured the noises behind the dataset and it will have given more importance to the outliers data and hence the outcome from the overfitting algorithm will not be accurate. The center graph represents the optimal way in which the machine learning algorithm should capture. Here the machine learning algorithm captures the trends of the dataset and hence the outcome will be accurate. So these graphs represents the underfitting, overfitting concepts in a classification analysis, wherein the left shows that the outcome from the machine learning algorithm will be underfitted and hence it will not be accurate. And in the right, the graph shows the outcome from a overfitted machine learning algorithm and in the center is the right fit, wherein the predictions will be accurate. Let's get to more details on what is underfitting. So the underfitting will have a high bias and a low variance and it generally will have less features. So if your training dataset is having less features, then it might result in underfitting. And the high bias means that the model assumes more about the form or trend the data takes and hence the accuracy of the output will not be good. And low variance means that whatever changes you do to the data, it makes small changes to the predicted values. So if we just take the scenario of a good fit or an optimal fit, it should be having a low variance as well as a low bias. And the machine learning model will have to learn from a reasonable number of features. And the machine learning model will perform well on a test data. So we have seen more about what is underfitting and what is good fit. Maybe I can just show you a quick example in the code to demonstrate what is overfitting and what is underfitting. I am going to reuse the same code that we had used for simple logistic regression. Here the input data for our code is going to be this, where we have the age and the employed column. And if the employed column is 0, it means that the person is not employed, and if it is 1, it means that the person is employed. So as you can see here, for smaller ages the person is not employed, and for the ages which is greater than 30 the person is employed. So this is a data set for logistic regression, but when I try to fit this data with a linear regression, then it will result in underfitting. I am going to quickly show you how that works and how it causes inaccurate results. I am going to use Jupyter Notebook, and in the first block I am importing pandas and matplotlib. Here I am not going to explain in detail about the code, but this is going to be just a demo for underfitting and rightfit. So I will just quickly go ahead. Here I am reading the data that we just saw into a data frame by name data, and when I run this block of code, you can see that the age and the employed columns are displayed. Next we can visualize the data. In order to do that, I am just using a scatter plot where I am just giving the age in the x-axis and the employed or not in the y-axis. And when I run this block of code, you can see that the data points are displayed here. So our machine learning algorithm should be able to make predictions which covers this data point. Now using this x and y, which is like age and employed, I am going to create a linear regression machine learning model. For that I am using the block of code over here where I have imported linear model from sklearn, and then I'm using linear regression class, and I'm building the instance of class and naming it as LIN model, and I'm creating a machine learning algorithm to fit the data, which is age. So age is going to be the independent variable and employed is going to be the dependent variable. So I run this block of code. You can see that the code has completed, which means that the model by name LIN model has been built. And now I'm going to use the predictions made by this model, and I'm going to check out how this model fits the data points. So I'm using the block of code over here where I'm labeling the x-axis as age and y-axis as employed, and then I'm constructing a scatter plot which is same as above here, as you can see, with age and employed. And then I'm going to create a plot wherein the actual age is plotted against the age which is predicted by the model, and I have mentioned the color as green. So when I run this block of code, you can see that the model is created as a green line. The predictions from the model is created in the green line, and you can see that the predictions does not fits the data sets at all. So this is a typical example of underfitting, wherein the model is not fitting to the data points and the predictions from this model will not be accurate. So choosing an incorrect model here has resulted in underfitting. So this data point better fits for a logistic regression model. I am going to use these data points and I am going to build a logistic regression model. For that I am going to use this block of code where I have imported logistic regression from the linear model package, and I am going to create a model giving age as the independent variable and employed as the dependent variable. So when I run this block of code, the logistic regression model is created. And then in order to check how this model fits to the data points, I am going to use this block of code where I have labeled age for x-axis, employed for the y-axis, and then the same way I am creating a scatter plot giving age in the x-axis and employed in the y-axis, and I am using the log model here in the last line where I am plotting a line with the actual age and the age predicted by the logistic regression model, and I am giving it the color as green. And when I run this block of code, you can see that the model perfectly fits to the data points. So this is the example of a right fit, and in this right fit both the variance will be low and the bias will be low. Now let's also quickly cover up in more detail about what is overfitting. In overfitting, the bias is usually low but the variance is high, and overfitting is created when there are too many features which is used to train the data set. So here the high variance means that the changes to our data will make large changes to the model's predicted value, and the low bias means that the model assumes very less about the form or trend the data takes. So we need to usually have a variance and bias trade-off. Increasing the variance will decrease the bias, and increasing the bias will decrease the variance. As you can see in the graph, the green line indicates the bias, and if you see that if the bias is high, then it is an underfit, and if the bias is low, then it is an overfit. The blue line indicates the variance, and as you can see, if the variance is low, then it is an underfit. If the variance is high, then it causes a overfit. So in order to have a good fit, we need to have a trade-off between both the bias and the variance, where both of them are relatively low, and correspondingly the error rate will also be low. When our model's bias is too high, then the mean squared error will relatively be high, and our model will perform poorly on the test data. So in order to rectify this, you will have to add more features to the model, and you will have to reduce the amount of training data, and basically having a high bias is more problematic than having a high variance, because the model predictions can become very inaccurate, and reducing the bias by increasing the variance will often take more effort. So when our model's variance is too high, then it means that our mean squared error will be too low, and the model performs again poorly on our test data. In order to rectify the high variance, you will have to actually reduce the number of features used in the model, and you will have to increase the amount of training data. So actually having a high variance is better and is less problematic than having a high bias, because we can apply algorithms such as regularization that can prevent our model from overfitting our data. So this is a brief overview about underfitting and overfitting. Hope you like this video. I will include the code which we have used in the description of the video. Please check out the description to know more about the other videos that I have made. And if you have not subscribed to my channel, please subscribe. Thank you very much.